Most developers are learning AI the wrong way, and it's not a small mistake. It's costing them time, it's costing them positioning, and in some cases, it's quietly costing them relevance in a rapidly shifting job market. Right now, thousands of engineers are spending months buried in machine learning theory, believing that's the responsible first step into AI. It sounds disciplined, it sounds rigorous, it sounds strategic, but in today's hiring market, it's often backwards. And if you don't correct the sequence early, you can lose a year without realizing it. The default path into AI looks academic. Start with linear algebra, refresh calculus, study gradient descent, understand backpropagation, derive the loss functions. This approach feels foundational. It feels like you're building from first principles. And intellectually, that's satisfying. But here's the important distinction. That curriculum was designed for people who build models from scratch. Most engineers entering AI today are not doing that. They're applying models that already exist. And that changes the optimal learning strategy entirely. The hidden assumption underneath theory-first learning is this: I need to deeply understand how models are trained before I can use them effectively. 10 years ago, that made sense. Today, foundation models are APIs. You don't retrain GPT. You integrate it, you orchestrate it, you manage its behavior. The real skill is no longer raw model training. It's controlled application, and those are two different domains. Let's look at market reality calmly. Very few companies are training large foundation models. That requires capital, infrastructure, and research teams. Most companies are doing something far more practical. They are integrating LLM APIs into products. They are building AI-assisted workflows. They are improving internal automation. They are enhancing customer experience. That's applied AI engineering. The market demand is not theoretical purity. It's operational reliability. When hiring managers evaluate candidates for GenAI roles, they are looking for signals. Not signals of academic exposure. Signals of execution. Did you ship an AI feature? Did it solve a workflow bottleneck? Did you measure performance? Did you account for failure cases? Hiring is risk management. Companies reduce hiring risk by choosing engineers who have already demonstrated applied capability. Execution reduces perceived risk. Theory alone does not. So why do smart developers still default to theory? Because theory feels structured. It has clear courses. It has certifications. It has milestones. It gives you the feeling of progress. But structured learning is not the same as strategic positioning. In fast-moving markets, you don't need completeness first. You need leverage first. And leverage comes from relevance. The first shift is mental. Move from thinking like a model builder to thinking like a system builder. You are not competing with researchers. You are competing with other engineers trying to integrate AI into real products. Your advantage is engineering maturity, architecture thinking, API design, performance optimization, production reliability. When you combine AI capability with engineering discipline, you become differentiated. That combination is powerful. Build one complete AI-powered workflow. Not a notebook, not a tutorial copy, a real, end-to-end system. For example, an internal knowledge assistant that retrieves documents, evaluates output quality, logs failures, and tracks token cost. Now you're solving engineering problems. How do I handle inconsistent responses? How do I retry safely? How do I reduce hallucinations? How do I manage latency? That kind of experience directly translates into interview conversations. Then focus on where AI breaks. Hallucinations, prompt injection, context window limitations, latency spikes under load, token cost explosions in production. AI in theory looks impressive. AI in production behaves unpredictably. Companies value engineers who anticipate failure before it becomes expensive. Reliability is the real competitive edge. Next, reposition your work. Don't say, completed machine learning course. Instead say, designed AI-assisted workflow reducing manual review time by 30%. That language signals readiness. Outcomes show competence. Metrics show maturity. Impact shows business alignment. Hiring managers think in outcomes. Your resume should too. Now, and only now, deepen theory. When you build systems, you encounter friction. Why does retrieval fail in edge cases? Why does temperature change response stability? Why does fine-tuning sometimes overfit prompts? Now theory has context. Now it strengthens your system intuition. Now it compounds your practical knowledge. That is targeted learning. And targeted learning is efficient learning. The developers who will win in AI over the next 5 years are not necessarily the ones who memorize the most equations. They are the ones who Ship AI features responsibly. Design systems with guardrails. Measure performance. Control cost. Improve reliability over time. Execution beats theory in applied markets. And the hiring market is an applied market. Position yourself accordingly. If you're currently buried in dense ML math and still don't feel job ready, this may be your signal to adjust the sequence. Build systems first. Solve workflow problems. Measure impact. Then deepen fundamentals with intention. The order matters. If you want to build an AI-proof career with strategy instead of guesswork, subscribe. We'll continue breaking down what actually matters in the AI hiring market, calmly, clearly, and without hype. Thanks for watching.